Find the work that needs to pump the water. It's not always the water, by the way. You will have chocolate and other liquids too. 6 meters, not complete. So it's not full. You see, the tank is not full of water because the tank is 10 meters high, but the water is 6 meters high. Out of the cylindrical tank that gives you the shape of the slice, it's going to be a circle, rectangle, triangle, where you're going to have triangles at some point, with height 10, and the radius is given as well. So, and then how do you pump the water? You can pump it through the edge, or you can make a fountain. So 15 meters above the bottom makes a little fountain, 5 meters tall. This is my sketch, which I did last time. A cylindrical tank, here it is. A cylindrical tank. The water is not at the top. The water actually is 6 meters high. And then there is a 5 meters fountain. How do I know? Because the total is 15. The total is 15 for water to go up, to be elevated up. And then I was trying to explain you this interesting idea. We create a sample slice. It's called in the green color, sample slice. Sample slice of not the cylindrical tank, of the water. And water takes, or liquid takes shape of the tank. So it is a circle. What is the slice? The slice is a circle. What is the volume of that circle? Pi area, let's just put it like so. Volume of the sample, or the slice. Let's do the slice. Volume of the slice is pi r squared times delta y. Let's discuss it again. Equals. So pi r squared comes from the shape of the slice. It's a circle. So sample slice, sample is a circle. Then volume will be pi r squared, which is area, times the width. Let me write it down. Area of the circle times the width, and we're gonna call it dy. Why?
Wait. Is this gonna be the height, width?
The width of the slice is the height, exactly.
Okay.
Yeah, good job. Thank you for asking this. This is very good, important point to understand. This is the width. How to describe this width? It's either projecting down to x-axis or y-axis. In this case, it's projecting to y-axis, so it's going to be delta y, not delta x. In general, horizontal slices, those are horizontal slices. It's a dy case, if you remember, called horizontal slicing. That's dy case. And here it is, the volume of the sample slice, the volume of the slice. Now, what we're going to do is, we're going to figure out that we need to lift all those volumes of each slices up. But then it depends on how heavy they are. Heaviness, in some problems, they're going to give you how heavy they are, and you just use that. Or we use the density times gravitational force as well. So in this case, let's do it this way. I'll write down. First of all, we do know what is the idea in the first place is to find work done to lift all of those slices up 15 meters up. But we know it is the force that we apply to do that, times the distance those slices have to travel. So just like I'm pushing the chair, I'm applying the force to push it and the distance the chair is traveling. There's going to be a work for each slice, and then we're going to add up all those tiny works, infinitesimals of works, and getting the integral. So what we're going to do here is, this work will be, this is an important thing to explain, the volume of this slice, and we just agreed on that. The volume of the slice, I will put it in this cute shape, pi r squared times the width of it, thickness of it, whatever it is, delta x times delta y. Now I will multiply by mass density, right? Thank you, with d, not g. Density with C, S. Okay, I did not guess. Density. Depends on the time of the day. Sometimes I guess, sometimes not. Density. Then it's heavy and goes against the gravity. It's not falling down. It's going up. So times the gravity. Gravity times the distance, how high we need to to lift those pieces. If we're lifting 1 meter, it's one thing. If we're lifting to 15th floor of the building, it's going to be another work. So times the distance for each slice to travel, the distance to travel. Very interesting. Someone asked also about how heavy the object is. So force equals weight and equals mass times gravity. Does that make sense? That's at least what I see from the book. Let me write it down for you, and then you can let me know if that makes sense. Maybe make just a second. I see your question. But what I see from the book is the force is the weight of this object, and that sometimes is broken down into mass times gravity, or just we give you the weight, mass times times gravity. Those are physical objects. Definitely, I just figured out how to help you with physics, which I'm not supposed to be doing at all. I'm not the right person to ask physics questions. You have problems, post them at the forum, and then physics majors in my both classes can definitely help you out to figure out. Or I go read the book, or I found people who are good in physics. That's exactly how you learn. You just figure out somewhere else. Yes?
I think volume of slice times density, that's just the mass, and then times gravity, and that's the newtons, and then they have distance,
I guess you're right.
and then the work is in
I guess you're right. The volume times density is mass. I guess you're right, yeah.
Mass times acceleration is force.
Times acceleration is force. Yes, I remember that.
Equals work.
Yes, I think you're right. Thank you. Definitely. No, thank you. Very good. Good job, people, that you know this stuff. So, volume of the slice, pi r, for this specific case. So again, volume will be different for each slice. Triangle or rectangle or whatever. For this specific case, we start writing it down in blue. Let me put it in green. For this specific case, we figure out pi r squared. Let me put r squared without plugging r. Capital or small, doesn't matter. We have only one. Times the height, okay? So width, in this case, delta y. The width, that is volume of the slice. Times density for water, 1,000 kilograms per meter cube. Times gravity, 9.8, that's a constant, meters seconds squared. Times the distance. The distance we will have to figure out, and I will not put it right now, the specific one, for a reason, you will see why. But also, when I put delta y, that is width. Volume is in meter cubes. That's what I'm trying to say. So maybe I should have some space. Times delta y, meter cubes. And then someone told me I should actually show you how beautifully it cancels out. Meter cube over meter cubes. And it becomes kilograms times meters over seconds squared, and that is work.
That's newtons.
Newtons. Oh, thank you. So it works, right? Newtons. Nice. I like when it works.
Times distance.
Thank you. Yeah, times distance, which we need to figure out also. Yes. Thank you. See, nice. You see, we have people to ask in this class, and that's what I like about classes with many majors at the same time. Now, let's finally finish the formula. So, that is very interesting because, as I told you, different books do it differently, and I found a way to show both. So that's very satisfying. So we're going to do it this way. Let's start writing the integral. This is work for the slice. So let me make the point. This is for the slice. Slice. But we're going to add up those slices together and then get the whole integral in pink. Work equals integral. We will have, I always put in front rho times g. That's what we had in the formula. I can actually scroll and show you this. Here it is, rho times g, area times distance, dy. So this piece, area times dy, is volume. D is distance, how to lift. A and B from where to where. So let's do it. These coefficients are mostly the same unless you have different liquids. They will give you different ones. And then you have a of y, d of y, dy from a to b, which c and d, but doesn't matter. So again, this in yellow is volume, which we already figured out. Volume of slice. Let's write it down. Integral. I will skip a and b on purpose. There's the reason for that. Rho is 1000 for water. Maybe I should write it down. For water. G is 9.8 times D. We agreed on what D is. Do you know? Not D. What is A of Y? Pi r squared. Good job. Pi r squared times dy, which is thickness. So we will have pi r squared. Let's finally plug it in. 5 squared. If you check the radius is given 5 squared. Let's go back. Not only I see it from my graph, because I was smart enough to sign it. 5 is radius. Radius is 5. But also it says here, radius is 5. Pi r squared, so 25 pi times, let's figure out the d and then dy. Nice, we're almost done. Only 2 things are missing. And those are 2 things that do not match between books. That is the interesting part. So this was very straightforward. I'm not saying it's easy, but at least this one is consistent between books. Because we're following, just a second, let me finish the idea and I will let you talk. We're following the topic of slicing. So we're slicing and getting the water. And before I move on and with the questions, check this out. This is the genius idea. Took me a while to understand this by myself. Look at this. You take this slice, it's in red, and lifting it up, not just to the edge, 10 meters, but also 5 extra because there's a fountain. The slice in the middle will travel this distance. The slice at the top will travel the most. The slice at the top, which is only 6 meters, will travel the least. Not only they're traveling different distances, each slice, and it will depend on y. Y is their location. If the slice is at the very bottom, from 0, it will travel 15 meters. That requires the most amount of work to travel so much. If y is not 0, it's somewhere before 6 or at 6, it's the least amount to travel. Moreover, all of them are traveling. And at some point, they have to go through all the distance from 0 to 15. Each slice will travel from at some moment to up to 15. So to indicate that in the integral, you have 2 ways of seeing it. For way number 1, which I will be consistent and it will be on the exam. Way number 1 is this. The y can be explaining how much water there is in a tank from 0 to 6. So water level. Then y is physical existence of water. If it's 6 meters, y is running from 0 to 6. But then we have to somehow explain in the integral how high each slice will go. The 0 level, the 1 level, the 1.7, the 6. They will go not top minus the bottom case, because actually it's dy revolving, but it's high minus low level. What is the highest level each slice can go?
15.
Exactly, 15. Y equals 15. And what is the lowest level each slice can be? 0. So 0 is not fixed because y can be different. That's why instead of 0, I'll be using y equals x. And x is running from A to B, from 0 to 6. And that is the confusing part. X is defined from 0 to 6. Not x, it's... Let's fix that. My x means unknown, the input. So actually I'm not supposed to say that. X is the level, water level, yes. Water level. The water level is running from 0 to 6. It's unknown. That's what I want to say about x, but let's not call it x. From 0 to 6. It's running up to 15, so it is a shift. 15 minus y, or y minus 15. One is not correct. Let's check which one is correct. That's the biggest mistake usually I see students make. 15 minus y or y minus 15. 2 ways of seeing it, highest minus lowest. What is the highest we can go? 15. Since this is the highest, it's the top. It goes first. Roof minus the floor. And the other way of seeing it, you plug numbers, make sure nothing is negative. If you plug the number, and no, you don't have to write this down, but if you plug y equals 0, then it will be we traveling each slice up to 15 from the level 0, right? That makes sense. If it's 0, it goes up to 15. If y is 6, because it only goes from 0 to 6, then this slice will travel 9 units up, which is the smallest amount it can be. At some point, y might become 15 or not. That is when the slice actually moves up above 6, goes up to 15, then the traveling is 0. 15 minus 15 is 0. It matches. If you write down y minus 15, you will get the negative numbers. If you put y equals 0, it means now it's traveling down, minus 15 units, that's down, which still works if you work with the pool and moving water down. So we're gonna have this case later. This is the hardest part to explain, and it's not the only way it can be done, which makes it worse. So I will leave this moment, put it in the box. This is what you're gonna have: multiple choice and free response on the exam. Lots of homework is done. This is the idea. Let me summarize and take questions. Why, if y represents the physical location of the water, it's from 0 to 6. 10 was not even mentioned here. 10 is the size of the tank. 10 was included over here. 10 plus 5 gives you 15. That's the height of the fountain. So how high the water will go. So elevation of the water or liquid. 15 minus y. Then the constants were easy to understand, I think. And then pi r squared, it's a shape of the slice, and specifically area of the slice, but it will depend on the shape. Square versus circle versus triangle versus a star, a heart, and so on. What do you think about that? Kind of like it took me a while to click, to be honest, all of this, because it's physics. I'm not a big fan of teaching physics. I'm not good at this. But I think I got it, so I'm wondering if my explanation makes sense. And then also you should think, how would you explain it, and then explain it your way as well, because it also makes sense. What do you think about that? The other way of seeing it is 4 water, yes. The other way of seeing it is to make a shift, which is U substitution. And that's what I don't appreciate, that well, it is very creative, I understand. Don't copy this problem. Number 7. But there is one more way to write down this integral, and it's gonna give you the same answer, which is technically speaking just U substitution. The other way you might see in physics books will be integral 1009.8 pi r squared. Everything is the same. The only difference now is, again, how we represent the shift or elevation of the water. So, 6. In this case, we take the difference. We take the difference between water level and the tank. 10 minus 6. 10 minus 6, that is 4. We go from 4 to 10 and put y here. Then when I saw this, I was a bit pissed. But then I realized, yeah, to be honest, it's a U substitution. If you choose this to be U, you change the limits of integration, and it's supposed to be correct. Explanation is this. They're explaining it this way. You see the gap instead, not the water lifting up. You see the gap between the height. Oh, I forgot to add 5, right? So plus the fountain. I think it's not mentioned here over the top. Plus 5. So plus 5. Let me break it into pieces. 10 is the tank plus 5. So it's 15. It's 15. But now it's from 4 to 15. Because instead of seeing the water floating up, and we're lifting each slice of water and throwing it away, lifting and throwing it away, instead of that, they see this idea. This is the empty piece. What this piece starts 10 minus 6, which is 4. 4 to up to 15, right? So we were lifting it up like so. This is the other way of seeing it, and it's also correct. I don't know. I will be consistently using the first method, but you will see some of the videos in other schools and other books, they showing this method. So just don't get confused. This is the idea. The answer should be the same. The answer must be the same. And again, I can see if I perform u substitution, if u is y, 15 minus y, then at 0, it is 15, and at 6, it is 9.
You have to add 5 to 4 too.
Oh, to 4, exactly. Thank you. See? The fountain. Thank you so much. Exactly. So it's going to be 9 to 15. The negative sign will show up in front because of the u substitution. So it flips it back and becomes not from 15 to 9, but 9 to 15. Good job. Thank you. Yeah. Very cool. Very good. I should do the experiment next week and ask some of you to explain it, if we still have questions, and see if your explanation is better. I'm very happy to know if someone can explain it better than me. I'm very open-minded that some things can be explained better. So I want to see how people do it and then maybe remember it. And then integration is simple. I'm not even going to integration part, because integration is just 15y minus y squared over 2 multiplied by all the constants. And you get the exact answer and happily move on. The answer is in joules. Joules, yes. My favorite way is the first way, not only because I understand it, this kind of makes sense, but also because we're elevating slices of water, and that's pretty cool. I feel like this is a pretty neat idea, that when you see this water, each slice is being elevated and thrown away, elevated and thrown away. How much work it takes if I'm pushing the chair every moment. That's different, that's additions of every moment of moving the chair. Each slice takes different work. It's much harder to lift the slice at the very bottom than at the very top. So we're accumulating those different works, and every time it's force times how heavy it is, times the gravitational forces and everything. So we're lifting it up. And think about that. Water versus chocolate versus honey. Honey has a viscosity. Pumping honey is even harder. And so additional stuff is happening there, which is a pretty interesting idea.